All right, so today we are going to be multiplying. Radical expressions. All right, in order to multiply two radicals, the index must be the same. In order to multiply two radicals, the index must be the same. So if we were going to multiply the square root of 2 times the square root of 3, all right, again, the index here is 2. It's not written, it's implied. So the index is the same. So what we get is the square root of 6. Now the square root of 6 doesn't have any perfect square factors, so it's in simplest form. If we had the third root of 5 times the third root of 4, all right, the indexes are the same, so we can multiply. That gives us the third root of 20. 20 doesn't have any perfect cubes as factors, so it's in simplest form. All right? Square root of negative 5 times third root of 2. All right, cannot be multiplied. Cannot multiply the square root of something times the third root of something. So I believe cannot be simplified. Index must be the same. Third root of negative 4 times third root of 2 gives us the third root of negative 8. Now, 8 is a perfect cube, and we have an odd index. So this can have a root, and the third root of negative 8 is negative 2. Okay? That's because negative 2 times negative 2 times negative 2 equals negative 8. Everybody okay with that? If the index is the same, you can multiply. If the index is not the same, then cannot be simplified. Fifth root of negative 5 times the fifth root of negative 2 is equal to the fifth root of -5 times -2, which is 10. All right. Now, if you multiply and your product under the radical can be simplified, well, then you need to take this one step further. And here's what I mean. If we end up with the square root of 24, all right, the square root of 24 has a factor that's a perfect square. Square root of 24 is equal to the square root of 4 times the square root of 6. And we've gone over this a little bit earlier in the year. The square root of 4 is equal to 2. So this simplifies to 2 radical 6. That is your simplest form. And then today you'll get exposed to simplifying some cube roots and possibly even some fourth roots. So let's say you multiply and your product is the third root of 24. All right, the third root of 24, it's got a perfect cube in it. It's got the third root of 8. No, that doesn't go there. It's got the third root of 8 times the third root of 3. Because 8 times 3 is 24. Now, the third root of 8, you can find it in your calculator. We're going to list some perfect cubes here in just a minute. But the third root of 8, that's equal to 2. Because 2 to the third equals 8. So this simplifies to 2 times the third root of 3. All right, so let's create a list here that might help you, hopefully will help you with your factoring. We're going to list some perfect cubes. The first perfect cube would be 1, because 1 to the third equals 1. Okay? The next thing you do to find the next perfect cube is you take 2 and you cube it. You can do it in your calculator. You can take 2, and then you want the button where it raises a power to a variable. And I'm struggling right now to find it on my calculator. All right, I'll find it here in a minute. But your second perfect cube is going to be 2 to the third. 2 to the third is 8. Okay? Your next perfect cube is 3 to the third, which is 3 times 3 times 3, which is 27. The next perfect cube would be 4 to the third power. 4 to the third power. The button that you're looking for that I was just talking about, on my calculator, it's right below the off button on the right-hand side. It's y to the x. And let's experiment with it. If we type 2, that button, and 3, and hit equals, we get an 8. So that's 2 raised to the third power. All right, 2, this button on your calculator screen. If you have a TI-30XA, it's underneath the off button. So if we do it again, 3 raised to the third, we get 27. 4 raised to the third, That's 64. 5 raised to the third is 125. 6 raised to the third, 216. And then we'll go 7 raised to the third. It's 343. And 8 raised to the third, 512. All right, so those are your first 8 perfect cubes. So another column, perfect. Perfect fourth roots. All right, perfect fourth roots, again, would be 1 raised to the fourth power is 1. 2 raised to the fourth, that's 16. And 3 raised to the fourth, it's 81. 4 raised to the fourth power, 256. 5 raised to the fourth, 625. And you're not going to need anything bigger than that when you're simplifying fourths. Okay? So these are perfect cubes because 1 is a perfect cube because 1 to the third equals 1. And 2 to the third equals 8. And 3 to the third equals 27. And 4, 5, 6, 7, 8 to the third equals 512. That's why they're perfect cubes. Okay? Same with these perfect fourth roots. 1 is a perfect root, but you don't use it because everything's divisible by 1. So 16 is a perfect fourth root because 2 to the fourth equals 16. And 3 to the fourth equals 81. 4 to the fourth, that's equal to 256. And 5 to the fourth, that's equal to 625. All right, so if you're dealing with anything with a 3 in the index, you're determining if any of these numbers are factors, and if they are, you factor them out. Questions? All right, then today on page 3, your practice is going to be on page 371. Ten through 18. And again, 7 topics this week. 7 topics will give you 100% quiz score. You can go up to 10 topics this week. If you learn 10 topics this week, your grade is determined by taking 10 and dividing it by 7. And that would yield you a 142% quiz score. So you can go over and above this week and be rewarded for it. Any questions?